Scaling objects. We're going to want to scale the solar system. We're going to have to take large planets and small planets and fit them to a scale so we can comprehend their size, similar to what we did in relative numbers. So here's the tallest human being that ever lived, Robert Wadlow. He only lived to age 22. His dad was 6 foot high. So we did the relative numbers where we scaled them. We're going to look at it slightly different now. Poor Robert didn't even live to his shoe size. Being a giant is very hard on the body on Earth. It makes me wonder if maybe if we sent giants to Mars, maybe they would thrive in the lower gravity. Who knows? Here's an example of another real-world giant. While Andre the Giant was tall, he was also very large in construction. So his hands were so big, he could use his two hands and cup the Princess Bride's entire head in his hands to keep her warm on the film shoot. He was apparently a very nice man. Matthew McGrory was artificially enlarged more than his regular height for the movie Big Fish. If you see the film Big Fish, you can see he's already suffering from spinal collapse and all sorts of problems due to his giantism. If we want to make a scale model of a real object, what we have to do is compare the real world size to the scale world size, and we will get what's called a scale ratio. Here's an example. In real life, Arnold Schwarzenegger is 74 inches tall. If we wish to make a 12-inch tall model, we divide the two and we get a ratio of 6.2. Arnold is 6.2 times bigger than his action figure. The reverse statement, Arnold's action figure is 6.2 times smaller than the real man. What if you inverted this calculation? You would still get a scale ratio, but instead of 6, you will get 1/6. Instead of 10, you would get 1/10. Now, here's my Arnold Schwarzenegger action figure. I want to make one for Edward Furlong to go along with it. So Edward Furlong is really 67 inches tall. Using the scale factor of 6.2, we shrink his height by this much. 67 inches divided by that scale difference of 6.2 gives us a 10.8 inch tall action figure. And this is how you do the entire dollhouse thing. You set up your scale ratio and then resize things to fit. Now, this made an action figure in inches from a real object measured in inches. This is not really going to work for really giant objects being reduced to the size of a sheet of paper. We wish to shrink people to fit proportionally on graph paper. Let's repeat the problem with Arnold. Instead of saying his action figure is going to be 12 inches tall, let's call it 12 boxes on the graph paper. So I get a cutout of Arnold and he fits by 12 boxes. Having converted one person to the desired size, we repeat this division on anyone else we want to add. So an elephant weighs 20 tons. I want to make a bar chart so an elephant's weight is 15 boxes high on the graph. So I take the real weight of the elephant, divide it by the number of squares on the graph square paper I want to use, and I get the elephant my graph paper would be 1.3 tons per box. It's odd number of steps, but it would work. But that's all it takes to scale objects down. And so we'll do this with the planets next.